Lab 5, Choose Your Own Adventure by Hudson Groover. For this lab, I threw a ball and tracked its X and Y position to see its change in energy as it bounced. So the purpose of this lab was to show the energy loss of the system, the tennis ball, and a preview of it is the observed does not match perfectly with the model. So during this, I had to use the velocity update formula to calculate the initial and final speed and the position update formula for my code. And then I'll be using the energy principle to calculate the loss of energy and the kinetic and gravity potential to see that. In this experiment, the system was the tennis ball and the surroundings was Earth. So our initial position was 0.1.5 meters and initial velocity 1.939 meters per second with a delta of 1 divided by 30 seconds because this was our frames per second of the video with a gravity of 9.8 and a drag coefficient of 0.229. So for our initial code, I set the ball position as that and the previously mentioned and ball velocity as previously mentioned, and everything else. And then I'll use this j hat y in order to show the direction of the drag, because depending on which way y is going, the drag will go in the opposite way. So then let's have our code. So it's a while loop, while less than 1.4 seconds, because it's the length of the video. It checks if the velocity is less than 0, and if it is, j has y because the drag will need to be going in the opposite direction, which you'll see here. So then we calculate the F net. So for the x direction, the only thing we have to worry about is drag, and y we have to worry about gravity and drag, which is velocity squared times the coefficient. And then I created an if statement to see if the position of y becomes less than 0 and the ball velocity is less than or equal to 0. And the reason I had to check for the velocity is because if the code checks that it's under than 0 and flips it to start going up again, but then it ticks again and it was still under, then it would just flip the velocity and it would forever follow down. So that's why this and is there. And then it will reverse the velocity because it's bouncing off and multiply by 0.73257 because that's what I calculated was the loss of energy of the system. And I also calculated the loss of energy for x. And so then we update everything, and then we will plot. So when we're looking at these two graphs, what we will see is both start at 1.5 and then fall, and they hit about near the same spot, and then they bounce, and they have they don't go nearly as high. And also, the velocity of both the x decreases and the y velocity stays the same, but it doesn't reach quite as high because it loses energy, so it actually decreases too. And then for the model, you'll see this happens, but it's much more clean because there's not changes in air, drag, and everything, and stuff like that. And also it goes under because it can't perfectly find when it hits 0 because it would need ticks very small, but we're working on 33 frames per second. So then when we put these next to each other with position versus time, you will see that the model lands a little ahead and also loses a little more energy. And you'll see this is because drag can change depending on the tennis ball surface. So the drag, it won't be perfect. And also there will be more. See, because possible source there is the spin of the ball. When the ball hits the ground, it loses energy from friction, which changes it into eternal rotation. And if the ball is already spinning when it hits, it won't exactly lose the perfect amount of energy. And also drag can change. So what does this mean? The difference in height reached and change in speed of x velocity. So this shows the loss of energy of 8.81 newtons to the surface and in the y direction, and 3.32 newtons in the x direction because of that spin and also some of the friction. And so what would have happened if the ball was spinning in a clockwise motion when it hit the ground? If it's spinning fast enough, it would actually increase in x speed, which is very interesting.